Crocodiles are masters of a lifestyle that humans often misunderstand. We call them cold-blooded, a term that makes them sound sluggish or fragile, but the reality is far more fascinating. They do not have cold blood. Instead, they are ectothermic, meaning they rely on the external environment to control their internal thermostat. So how exactly does a crocodile regulate its body temperature? The short answer is that they are master behavioral engineers, using a combination of solar basking, water dynamics, a uniquely adapted cardiovascular system, and even a gaping, toothy grin to maintain a remarkably stable internal temperature. As the first rays of sunlight hit the riverbank, the crocodile hauls its massive body out of the water and onto the mud. It aligns its body perfectly perpendicular to the sun's rays, maximizing the surface area exposed to the heat. If you look closely at a crocodile basking in the morning sun, you are looking at a living solar panel. Those rugged, bony plates on their backs are called osteoderms, and they are not just for armor. Beneath those hard shields is a massive network of tiny blood vessels. As the sun warms the plates, it warms the blood rushing through those vessels. The crocodile's heart then pumps this freshly heated blood throughout the rest of its body, raising its core temperature and waking up its muscles for the day ahead. But what happens when the sun gets too hot? By midday, the tropical heat can quickly become lethal. Because crocodiles lack sweat glands, they cannot cool down the way we do. If they stay on the bank too long, they will literally cook from the inside out. This is where their behavioral engineering takes a dramatic turn, and it involves a behavior that often terrifies onlookers, but is actually a sign of a crocodile just trying to chill out, mouth gaping. You have probably seen photos or footage of a crocodile resting on a riverbank with its jaws wide open, exposing a mouthful of razor-sharp teeth. It looks like an aggressive posture, a warning to anyone thinking of stepping too close. In reality, it is the crocodilian version of panting. The lining of a crocodile's mouth is incredibly thin and packed with moisture and blood vessels. By opening its mouth to the breeze, the moisture evaporates, cooling the blood in the mouth cavity, which is then circulated back to the brain and body. It is a highly localized, highly efficient evaporative cooling system. When mouth gaping is no longer enough to beat the midday glare, the crocodile executes the ultimate temperature control move. It slips back into the water. Water changes temperature much more slowly than air, making it the perfect heat sink. If the crocodile is too hot, it dives into the cooler depths. If it needs to stay relatively warm but wants to avoid the direct, burning sun, it will float just beneath the surface, leaving only its eyes and nostrils exposed. By shifting just a few feet between the hot bank, the warm shallows, and the deep, cool currents, a crocodile can keep its body temperature within a remarkably narrow, optimal range of about 30 to 35 degrees Celsius. What makes this behavioral dance truly incredible, though, is the hidden machinery operating inside the crocodile's chest. They possess the most complex cardiovascular system of any vertebrate on Earth. While a crocodile is basking, its heart can actually alter the route of its blood flow. Through a specialized valve called the foramen of Panizza, and by constricting certain blood vessels, a crocodile can shunt oxygen-poor blood away from its lungs and send it directly back out to the body. Why would it do this? Because carbon dioxide-rich blood helps alter blood pH, which enhances oxygen delivery to the tissues and helps generate and retain metabolic heat while basking. Conversely, when the crocodile enters cold water to dive, it can slow its heart rate down to just a few beats per minute, a phenomenon called bradycardia, and restrict blood flow to its outer limbs, keeping the warm blood trapped deep within its core to protect its vital organs. They are, in essence, operating a manual thermostat inside their own circulatory system. This entire strategy of temperature regulation is not just a biological quirk, it is the secret to their evolutionary longevity. Because crocodiles do not waste massive amounts of energy-burning calories to create internal body heat the way mammals do, their energy requirements are incredibly low. A crocodile needs less than 10% of the food required by a mammal of equivalent weight. This efficiency means that when food is scarce, or when environmental conditions turn harsh, a crocodile can simply lower its temperature, slow its metabolism, and survive for months on a single meal.